today we are going to really get into a place where geometry and algebra overlap. We've got a couple definitions from geometry, but then we've got some formulas that you learned in algebra that we will put together and kind of work with. So let's go ahead and cover our definitions before we get into any of the actual problems that we're working on. The first definition you need to know is midpoint. The midpoint of a line segment divides that segment into two congruent segments. Now, this is one of those nitpicky things. It doesn't split it in half. It doesn't split the segment into two equal pieces. It is two congruent segments. Now, what can we do with congruent segments? Well, if they're congruent, they have the same length, so we can set them equal to each other because we know that their measures are the same. So if you look at this segment AB over here on the right, M is the midpoint, so AM is congruent to MB. So segment AM and segment MB are congruent pieces. That means they're identical. Because we know that their measures, their lengths are equal. So if we had, let's say this was 9x and this was 27, we could set them equal to each other, and we will do that here in a few moments and solve for x. So that's midpoint. A segment bisector, that's the other big vocabulary word we have today. Segment bisector is anything that goes through that midpoint. So it's a point. It could be the midpoint itself. It could be another line segment. It could be a ray. It could be a line. It could be a plane. So any of those things could be a segment bisector, and that just means it goes through the midpoint. So if you know something's a bisector, you know that it also splits the segment into two congruent pieces. So here in this figure on the right, we're told that the green line, CD, is a segment bisector, so we know that these two pieces of AB are congruent. So AM is congruent to MB, and we know that their lengths are equal. So just like we did before, we could set them equal to each other. And the word we use is bisects. Remember, bi means two. Intersect means to cross over or to share points. So a bisector shares that point that splits the line segment into two congruent pieces. So if you saw in a problem such and such bisects segment FG, you would know that FG is split into two congruent pieces. Alright, example 1, in the skateboard design shown with an N, VW bisects XY at point T. So we know that, okay, VW is this part I just marked in red. It bisects, I'm going to use green, XY. Okay, because of that, we know that XT and TY are congruent. So I'm actually going to write that in. XT is congruent to TY. We know that because VW bisects XY. So if XT is 39.9 centimeters, find XY. Now, XY is this whole thing. So if XT is 39.9, we know that TY is also 39.9. Then we can go back and use the segment addition postulate that we learned last time, and we could say that xt plus ty equals xy. and there are no bars on top because we're talking about their lengths. So 39.9 plus 39.9 equals the length of xy. So we could figure out that xy is 79.8 centimeters long. Because we knew one piece, we knew the other one was the same, and so we added them together. You could just, in the case of bisectors, you could just multiply by 2, it would get you the same thing. But it's still based on that segment addition postulate. Alright, example 2. Point M is the midpoint of segment VW. Find the length of VM. So we're trying to find the length of that piece alone. Now, we know M is the midpoint, so we know VM is congruent to MW, because that's what a midpoint tells us. So we know that the length of VM equals the length of MW. So we could say 4x minus 1 equals 3x plus 3. So again, we're back to solving an equation. So we're always using algebra in our geometry class. If we subtract 3x from both sides, it's going to give us x minus 1 equals 3. We'll add 1 to both sides. That's going to give us x equals 4. It does not ask us for x, though. Make sure you read to see what you need to find. It asks us to find VM, which is this piece. So VM, this is just where we plug in. It'll be 4 times 4 minus 1. And we plugged 4 in there because that's what x equals. So that will be 16 minus 1. So VM equals 15. So make sure you've checked to see whether you're solving for x or you're actually finding the length of one of the segments. Now, on a graph, if you know the coordinates of 2 points, you can find their midpoint. You can find the coordinates of their midpoints. So if we had, okay, so the formula for midpoint, I'll just go ahead and write it in. It's basically we are averaging our x's and averaging our y's. So this would be x1 plus x2 divided by 2, y1 plus y2 divided by 2. For midpoints, it's always divided by 2, and it's always the x's together, the y's together. And there are parentheses around here because the answer needs to be an ordered pair. So we've got segment RS, and we've got its coordinates there. So we want to find the coordinates of the midpoint. I like to go through and label these. Sometimes I don't do it, but especially right now as you're getting started, I'm going to label these. So that's x1, y1, x2, y2. And remember those subscripts, the small 1's and 2's, tell us the 1 and the negative 3 go with the first point, the 4 and the 2 go with the second point. So our midpoint will be our two x's added together. So that's going to be 1 plus 4, then we'll divide that by 2. We'll add our y's together, it'll be negative 3 plus 2, and we'll divide that by 2. So 1 plus 4 is 5. Negative 3 plus 2 is negative 1. And it's totally okay. In fact, for me, it's preferable to just leave these as fractions. If you wanted to, you could make it 2.5 and negative 0.5. That would be okay. I'm not going to count off points by any means, but I prefer you to just leave them as fractions. So that's using the midpoint formula, which you will need to know. Your quiz, I'll give it to you, but on your test, you will need to know that. Alright, example 4. This one's a little bit different, still using midpoint formula. The midpoint of segment VW is M at -1, -2. One endpoint is W at 4, 4. Find V. So for this one it's a little bit different because we need to split up our X's and our Y's in order to do it. Now, we know that the coordinate for our midpoint, the X coordinate for our midpoint is -1, and we know that the X coordinate for W is 4, but we don't know the other X coordinate. So we've got -1 equals 4 plus X sub 2 over 2. So I still used the midpoint formula. I'm going to call this X sub M because it's the midpoint. Still use the formula, only I plugged in here and here. And then we have to solve for the other one. Well, we've got the whole thing divided by 2, so we need to multiply by 2. So that means -2 equals 4 plus X sub 2. Then we'll subtract 4 from both sides. And that's going to give us -6 equals X sub 2. So we know the X coordinate is -6. We will repeat the exact same process for our Y. We know the Y of the midpoint is -2. We know the Y for W is 4. And we're trying to find Y sub 2. We'll multiply by 2 to get -4 equals 4 plus Y2. Then we'll subtract 4. So we'll get -8 equals Y sub 2. So we put those two together as an ordered pair. So V is found at -6, -8. Now, that's finding the midpoint. What if we wanted to find the length, the distance between 2 points, or the length of a line segment, and we know the coordinates for that? Then we use the distance formula. And the distance formula, it's based on Pythagorean theorem, which you've seen, but you might not remember. It's okay if you don't right now. So distance formula is the square root of x2 minus x1 squared. So you need to do the subtraction and then square it. And then we will add that to y2 minus y1 squared. And what we're going to do is break this down and do it in pieces. So, for example 5, let's label our points. That's x1, y1, x2, y2. I'm just going to go ahead and plot this real quick. And you can see that we can't just count the blocks because it's a diagonal line. So let's plug everything in. We'll say the length of RS equals, take big square root sign, put your parenthesis in. x2 was 4, x1 is 2, square that. I'm actually going to color code this to show you what I do in each step. So that would be 4 minus 2. y2 is -1, y1 is 3. No. And the square root is what I'll end up doing down here. Okay, sorry about that. So first I'll do what's in blue. And the RS equals will stay the same. Still have a big square root. 4 minus 2 is 2. Negative 1 minus 3 is negative 4. Okay, so the first step I did what's inside those parentheses. Both of them are going to be subtraction problems. The next thing I'm going to do is square these, and I just realized I wrote the wrong number down there. So the next step will be to square both of those. Now, let me pull up your calculator, or a calculator. When you are squaring, it's good practice to always put it in parentheses. So our first number was 2, so we would do parenthesis, 2, close parenthesis, and the square button is off to the left, almost right in the middle, squared, and that's going to give us 4. So that will be 4. Now the other one is the one where people tend to make mistakes. Our other number is negative 4. Now if I put in negative 4 squared, it's going to give me a negative number. You can never square something and get a negative number, because a negative times a negative would give you a positive, and a positive times a positive would give you a positive. So that's why it's good practice to always put it in parentheses, because that's going to square the negative sign also. The first way we typed it in, what it does is 4 squared and then puts a negative in front of it. So we want it to be positive 16. So just remember, when you square something, you should always get a positive. Alright, so that'll be 4 plus 16. Moving on to our next step, we'll add those two together, and that will give us 20. I'm going to do these in the same line. Now, the square root of 20, we will do that in our calculator. If you notice, above the x squared sign, there's a little square root sign that's called a radical. It's in blue, which means we need to do second x squared to get it to show up. And then we'll type in our number. So that's going to give us 4 point, and in general do 2 decimal places unless you're told otherwise. So 4.47. The third place after the decimal is 2, so that's less than 5. So we'll leave it at 4.47. So 4.47. So our final answer, RS, equals 4.47. Alright, for example 6, we're basically going to run through it again, we just don't have the graph. So we've got x1, y1, x2, y2. And I'm not going to try to color code it this time. So the length of AB equals, okay, we've got parentheses squared plus parentheses squared. x2 is 1, x1 is negative 3. y2 is negative 4, y1 is 2. So inside our parentheses, we'll do 1 minus negative 3. Well, 1 minus negative 3 is the same as 1 plus 3, so that will be 4. On the other parenthesis, we've got negative 4 minus 6, excuse me, negative 4 minus 2, and that's going to give us negative 6. Then we will square both of them. 4 squared is going to give us 16. negative 6 squared is going to give us positive 36. Squaring always gives us a positive. If we add those together, we get 52. And so the last thing, we'll jump to our calculator to do second x squared 52. That's going to give us 7.21. The third place is less than 5, so we'll leave it alone, 7.21. So AB equals 7.21. And technically, it doesn't equal that. It is approximately that. The approximate symbol is like equals, but there's squiggly lines, which basically says we had to round. So it's close to this, but not exactly. And our last question, does it matter which pair you choose first? It does not, because when you square it, negatives go away. I'm going to rework the same problem, but this time I'm going to reverse my x's and then reverse my y's. So we would have negative 3 minus 1 squared plus negative 2 minus negative 4 squared. Negative 3 minus 1 will be negative 4 squared. Negative 2 minus negative 4. Excuse me, that should be positive 2. 2 minus negative 4 will give us 6. And we'll square that. Negative 4 squared is 16. Positive 6 squared is 36. Add those together, we get 52. And that's the same thing we got before. So we know the square root has to be 7.21. So order does not matter as far as which point you start with. The important thing is that you're putting the x's together and you're putting the y's together. It's the same way with midpoint, although you do always need to show your x first when you're writing your ordered pair. So midpoint divides a segment into two congruent segments. We can set those two equal to each other to do some work. Then midpoint formula and distance formula are formulas that we can manipulate and find things out on a coordinate plane, so we can combine our geometry and our algebra ideas together. So get ready to do the practice problems. Make sure you fill out that Google form. Good luck.